Hi, hello, dear students. Welcome back to DSM Math tutorial. So, in the last sessions, we have discussed about Fourier series concept, problems on Fourier series. Then we have discussed discontinuity function using Fourier series expansion. So, everything. Now, today I am going to discuss one more very important and very interesting concept with respect to Fourier series, that is even odd function concept. See what happens in earlier problems, they'll give some function, we are finding a0 value, we are finding an value, we are finding bn value. Okay. So, for simple problem it is okay, but some difficult problem it takes a lot of time. So, if we know whether the function is even or whether the function is odd, then we can easily reduce the steps. So, that is nothing but even odd function concept in Fourier series. Okay, so as I told, we know that the standard form of the Fourier series is in the form f of x equal to what? A0 by 2 summation n equal to 1 to infinity a n cos n pi x by l plus summation n equal to 1 to infinity b n sin n pi x by l. This is the standard form of the Fourier series. With respect to this, we are finding a0 value, we are finding an value, we are finding bn value without applying the even odd concept, so it becomes sometimes tedious. Okay. Now, how to find out even odd function and how to operate Fourier series for even odd functions? That is the task. We know that there are two types of standard limits. One is what? Minus L to L. Another one is what? 0 to 2L. These are the two standard types of arbitrary limit. Whichever the limit they may give in the problem, our job is to compare the given limit with these two standard form of the limits. Then we have to equate L value and we have to substitute in the required results. Okay. Now, how to find out whether the function is even or odd using this limit minus L to L. Let it be, let f of x is defined in this interval minus L to plus L. Okay, so that minus L to plus L arbitrary. We can take any value, minus pi to plus pi, minus 3 to plus 3, minus 2 to plus 2, minus pi to plus pi, like that. Minus pi by 2 to plus pi by 2, whatever it may be. So in general I have written arbitrary. Suppose if I define this f of x in this interval minus L to plus L, and how to check whether it is even or odd? The procedure says you have to replace x by minus x with the given function. Then if we are getting positive of f of x, then this is called even function. If I am getting negative of f of x, then that is called odd function. Okay, if I am getting positive of f of x, that is our even function, negative of f of x, that is our odd function. So for even function, you can directly write bn value as 0. You no need to operate the formula bn equal to 1 by l integral 0 to 2l f of x sin n pi x by l into dx. No need at all. If you know the given function is even, you can directly write bn as 0. In the same way, if you know that given function is odd, you can directly write a0 and the n value should be 0 without applying the formula. I hope it seems very good, right, dear students? It's very simple, no? So instead of finding a0 an by applying the formula, if we know even odd concept, I can directly make them as 0. Okay? So bn, if I know the given function is even, bn should be 0. So I'll take one simple example. Let it be sin x. Let f of x is defined as sin x in the interval minus pi to pi. Minus pi to pi. So on comparison, what is clearly L value is pi. So we know that how to find out even odd. When the function is defined in the form of minus L to plus L, we have to replace x by minus x. So here if I replace x by minus x, so what happens it is sin of minus x, right? So sin of minus x is nothing but minus sin x. Okay? Minus sin x means minus as it is. Sin x is what? Our f of of x. Function f of x. See, after replacing x by minus x, I am getting negative of f of x. So therefore it is odd function. Therefore it is odd function. For odd function, our a0 and an should be 0. a0 and an should be 0. In the same way, I will consider another function f of x equal to cos x in the interval minus pi to pi only. In the interval minus pi to pi. Now what happens? We know the result. We know how to check whether it is even or odd. Since it is in the form minus L to L, I have to replace what? H by minus x. So what happens? It is cos of minus x. We know that in the trigonometry, cos of minus theta is plus cos theta only. That means cos of minus x is what? Plus cos x only. You will not need to write plus, it is understood. But for your convenience purpose, I am writing plus cos x. So plus cos x is nothing but our f of x. See, after replacing x by minus x in the given function, I am getting positive of f of x. Therefore, it is what? Even function. For even function, Bn should be 0. Bn should be 0. I hope you got it. Okay. So it is very simple. If the function is odd function, we can directly write a0 n equal to 0. If the function is even function, we can directly write bn equal to 0. Here the important observation is which term you have to replace to check whether it is even or odd. And in which limit form, that is very important. When it is minus L to L, we have to replace x by minus x to check whether it is even or odd. Now another form of the standard limit is what? 0 to 2L. So in this case, you have to replace x by 2L minus x. Remember, if the limit is of the form 0 to 2L, you have to replace x by 2L minus x in the given function. If we are getting positive of f of x, then this is called even function. If I am getting negative of f of x, then this is called odd function. Same for even function, bn should be 0. For odd function, a0, an should be 0. Okay, this is universal truth, that is. For even function, bn should be 0. For odd function, a0, an should be 0 in Fourier series. Now, I'll take one simple example. Same sin x cos x only I'll take. Let f of x should be sin x. Let f of x equal to sin x. In the interval what? I'll take 0 to 2 pi only. Standard limit. 0 to 2 pi. Now I want to check whether it is even or odd. So we know that how to check even or odd. So it is of the form 0 to 2L. Okay? 0 to 2L means what? L equal to pi. So what we have to replace? 2L minus x. So x should be replaced by 2 pi minus x. Why? Because L1 is pi. So what happens in this? Sin 2 pi minus x. Now what happens in this? Sin 2 pi means 360. 360 minus x. In the fourth quadrant, when you draw the trigonometry, first quadrant, second quadrant, third quadrant, fourth quadrant. So 360 minus x in the fourth quadrant sign will be negative. So it is minus, and 360 minus x is sin x itself. Okay? So minus sin x. Therefore it is what? Minus of f of x. Because our f of x is sin x, I have minus sin x minus f of x. It is odd function. Clearly it is odd function. For odd function what? a0, an should be 0. a0, an should be 0. I take same cos only. Instead of sin x, if I take cos x in the same interval 0 to 2 pi. So what happens now? You have to replace x by 2 pi minus x, right? 2 pi minus x cos of 2 pi minus x. Again, fourth quadrant, cos and its reciprocal is positive, remaining all are negative. So it becomes plus, and cos 360 minus theta, cos theta itself. So it is cos x. So now what happens? It is plus f of x. After replacing x by 2 pi minus x, I am getting positive of f of x. Therefore it is called even function. Even function. For even function, bn should be 0. Now you can see how it is easy. We have done first problem x square in the interval minus pi to pi. So if we know that, I can directly x square by looking at only we can tell that it is even function. Bn should be 0. But without knowing even odd, I cannot write bn equal to 0 directly. Okay? So I have to find out using formula. So I hope if you know this, we can easily reduce step and it can save a lot of your time. It can save a lot of your time. Now, this is one part. Sir, this is you have written how to find out even odd function when we have discontinuities or when we have discontinuous functions or piecewise continuous functions. That is also simple. We'll go one by one. See how usually discontinuous functions are expressed. F of x equal to one function, any function of x, and here another function of x, or it may be constant, whatever it may be. I'll just take both are functions of x. So this defined in the interval minus L to 0, and this defined in the interval 0 to L. 0 to L. Again, whichever the problems they may give in the Fourier series, only there are two standard limits, minus L to L, 0 to 2L. So you have to compare, find out L value and simplify. That's it. Now, so when we have discontinuities or piecewise continuous functions in this form, how to find out whether it is even or odd? Very simple. Okay? See, this function f of x is split as two sub-functions. The first function has the interval minus L to 0. Second function has the interval 0 to L. Okay. Now, we have to replace x equal to minus x in phi of x. X equal to minus x in phi of x. If I am getting positive of plus of xi of x, another function, positive of xi of x, then this is called even function. If I am getting negative of xi of x, then that is called odd function. Okay, very simple. There are two functions will be given. You have to denote first function as phi, second function as xi, and you have to replace when the limits in the form minus L to plus L. You have to replace x by minus x in phi of x. If I am getting plus xi of x, it is even function. Minus xi of x, it is odd function. In the same way, when it comes to limit 0 to 2L, same here also, the function is always in this form, phi of x, 0 to L, and xi of x, L to 2L. You can see, you should observe the limits carefully. It started with minus L, ended with plus L, so it is of the form minus L to L. It started with 0, ended with 2L, it is of the form 0 to 2L. Since these are arbitrary limits, in particular if they are given any values, you are compare this and the standard limit. That's it. Here also, what we are supposed to do, let x equal to 2L minus x in phi of x. In phi of x. If I am replace x by 2L minus x, if I am getting positive of xi of x, then this is even function, and negative of xi of x, and this is called odd function. Negative of xi of x, that is called odd function. So this is how to find out even odd function. See, if you don't know, sir, it is very difficult, or we are not preferable, we are not comfortable with this, you go with general method. Those who really want to save their time and those who are very good in mathematics, you can use the shortcut method. Okay, it is very useful when you face the competitive exam or some other entrance exams. So now, sir, if we know even odd function concept, then what may be the formula? Will the formula will be same? No, that is the slight change in the formula. Okay. If we are applying even odd concept for any Fourier series function, then the formula, how we are writing a naught? In the general formula, we are writing 1 by L. Okay, but in the after applying the even odd concept, the formula becomes 2 by L. So integral 0 to L f of x dx. an is also 2 by L integral 0 to L f of x cos n pi x by L into dx. bn equal to 2 by L integral 0 to L f of x sin n pi x by L into dx. These are the general formulae when we are applying even odd function concepts for the Fourier series expansion. Instead of writing 1 by L, it is 2 by L and 0 to L. So how these formulae are derived? Okay? Using basic integration property, that's it. So what are the properties? There are two properties. Minus a to plus a, f of x dx. It becomes 2 into integral 0 to a, f of x into dx when the given function is a1. Another one is what? 0 to 2a, f of x dx. This will become 2 into integral 0 to a, f of x dx again when the given function is a1. Okay, so using that formula we have derived. So derivation I have not explained here because that is not necessary. You should remember this one. So these are the fundamental formulae to derive all these things. I hope you got it. Okay. Now, sir, will all the functions are even or odd functions? No, it's not like that. Sometimes we may get the functions like neither even nor odd. Neither even nor odd. For example, I'll take one simple polynomial term. Let f of x equal to x square minus x cube in the interval minus pi to pi. In the interval minus pi to pi. Now we know how to check whether it is even or odd. We have to replace what? X by minus x. So what happens? It is minus x whole square minus x whole cube. Minus x whole square means x square, minus x whole cube means minus x cube, minus into minus plus x cube. Now you can see this is not equal to plus f of x and it is not equal to minus f of x. Okay, so these kind of functions are called neither even nor odd functions. So for this we cannot apply even odd function concept. We have to apply general Fourier series expansion method. Similarly, for exponential term e power minus ax also. See, when you are replacing x by minus x, only this power will change, but here sign will not change. Okay, so that is the reason. Usually exponential also, be careful while checking even odd, and polynomials like you have to be careful. Okay, so I hope you people got one good clarity with respect to even odd function concept and the formula for even odd function problems. Now I will move on to one simple problem with respect to this even odd function concept. Guys, it is very simple method. Fourier series is very simple technique. Only it needs basic integration. This I repeatedly tell in all the sessions. Why? Because at least you should practice basic integration. That's my intention. Now, if we go with general method, as I told, it becomes tedious. First, we will check whether it is even or odd. If it is neither even nor odd, then we have to go for general method. If we know it is even or odd function, then we have to go for the shortcut method. Now, there are two functions is given. Okay, let's write them. Phi of x equal to what? X. And psi of x equal to what? Another function is what? X minus 2 pi. X minus 2 pi. Now you can see the lower limit is 0 and upper limit is 2 pi. This is of the standard form 0 to 2 pi. Okay? 0 to 2 pi. Now we know when with the limits of 0 to 2 pi, we have to replace x by 2 pi minus x in psi of x. That is, to check whether it is even or odd, it becomes 2 pi minus x. Now what happens? X becomes 2 pi minus x. Now you can see here it is x minus 2 pi, it is 2 pi minus x. So blindly don't try it is neither even or not. First you try to take minus outside, check if it is simplified form equal to this or not. Now what happens? If I take negative outside, so it becomes x minus 2 pi. Yes, I am getting xi of x, right? Xi of x is x minus 2 pi only. So what happens? It is minus of xi of x. You can see after replacing x by 2 pi minus x, I am getting negative of xi of x. Therefore, the given function is odd function. F of x is an odd function. Okay, for odd function a naught an we can directly write as 0. You no need to find out a naught an value using integration formula because it is an odd function. It is an odd function. Now we have to write directly Bn formula. We know when it is odd function, the formula will be 2 by L integral 0 to L f of x sine n pi x by L into dx. That is equal to, clearly what is the L value? See, it is of the form what? 0 to 2L. That means L equal to what? Pi. L equal to what? Pi. So Bn equal to, rewrite, I will just write it here. It is 2 pi integral 0 to L. L is what? Pi f of x. See, two functions are there. Okay. So in 0 to pi, which function it is there? X. Okay. So we write x into L value is what? Pi. Pi and pi cancel. That is sine nx dx. Sine nx dx. 0 to pi, the function is defined as x. I cannot take this function. Why? Because it is defined in pi to 2 pi. But the limit are 0 to L. So 0 to pi. Now we know integration by parts method. We have to operate. So Bn equal to 2 by pi integration by parts x as it is integral of sine nx dx minus differentiation of x will be what? 1 double integration of sine nx dx. Next one differentiation will be 0. 0 into something 0. No need to write that. 0 to pi. Now what happens it is 2 by pi x into integral of sine is what? Minus cos. Okay. So x into minus cos nx divided by coefficient of x is what? N. Minus double integration of sine. One time integration we have here, minus cos nx by n. If I integrate this one more time, cos become plus sine integration. Okay, this minus will be written as it is. This minus and this minus become plus. So it becomes, sine becomes cos, cos becomes again sine. Sine nx divided by n square, because we have integrated twice between the limit 0 to pi. Now we know the standard trigonometric result. Sine 0 is 0, sine n pi is 0. So this term no need to operate limits, because if you operate also you will get 0. Sine n pi is 0, sine 0 is 0. So I will write remaining terms. Bn equal to 2 by pi, that minus 1 by n I will write outside, minus 1 by n. So remaining term x cos nx between the limits 0 to pi. Now simplify this further. Since it is multiplication, I write it outside, minus 2 divided by n pi. When you operate upper limit, pi cos n pi, pi into cos n pi, minus lower limit 0, 0 into something 0. Or Bn equal to minus 2 divided by n pi, pi into cos n pi value is what? Minus 1 over n. So pi cancel, minus 2 minus 1 over n divided by n. Now I can simplify it further. Why? Because minus is nothing but minus 1. Minus 1 over n. When bases are same, we can add the powers. X power A into X power B is nothing but X power A plus B, right? Minus 1 into minus 1 power n is what? 2 into minus 1 power n plus 1 divided by n. So that is our Bn value. That is our Bn value. Therefore, substitute the Bn in the required Fourier series. F of x equal to summation n equal to 1 to infinity Bn value is 2 into minus 1 power n plus 1 divided by n sin nx. So this is our required Fourier series. So once we got the Fourier series, they are asking us to deduce this result. It is in terms of numerical value, numbers. So if I want to eliminate this sign, the only option is I have to take substitution for x. In the previous class also I explained, when the right hand side is sin x, the possible substitution for x is 90 degree because sin 90 is 1. In all other cases it becomes 0. When you have cos, the possible substitutions are 0 and pi. Okay, so now in this f of x, we'll just write here. So f of x, let x equal to what? Pi by 2. So I am very much clear here why I am taking x equal to pi by 2, because the sign is function. It has the value only for 90, sin 91. If I take x equal to 0, what happens? 0. If I take x equal to pi, it becomes 0. So sin 90 is 1. If I take 0 and pi, the entire term will become 0. I cannot get the series. That is the reason x equal to pi by 2. Now when you take x equal to pi by 2, what happens left hand side? That is very important. Two functions are there. Which function I am supposed to take? 0 to pi, pi to 2 pi. 90, pi by 2, where it lies? In between 0 and pi. In between 0 and pi, this pi by 2 lies. Therefore, we have to consider f of x as x. When f of x equal to x, since I am taking x equal to pi by 2, so what happens? F of x is nothing but pi by 2. Because this x equal to pi by 2, 0, x, pi. So pi by 2 somewhere here. For pi by 2, f of x value is x. So I am taking x equal to pi by 2. If I take x equal to pi by 2, this becomes pi by 2. Function becomes pi by 2. That is equal to summation n equal to 1 to infinity to minus 1 power n plus 1 divided by n sin n pi by 2. Because x value pi by 2 I have taken. Now you can see, if you take n equal to 1, sin 90, 1. Similarly, minus 1 power 1 plus 1 is what? Minus 1 whole square. Minus 1 whole square is what? Plus 1. Plus 1 into 2, 2. When you take n equal to 2, 2 and 2 cancel, sin n pi or sin pi, it becomes 0. So for even values of n, it becomes 0. When you take n equal to 3, sin 3 pi by 2, so it becomes minus 1. Right? So we are getting minus 1. So now, I'll write this 2 also this side, pi by 4. I hope I have explained everything clearly. If you keep on substituting the even values of n, this becomes 0. When you take odd values, it will start with alternate signs. Okay? Just substitute and simplify. So, pi by 4, first n equal to 1, I am getting 1. N equal to 3, so it becomes 1 by 3. So, this becomes minus 1 by 3 plus 1 by 5, etc. This is what they are asking. Okay, so very simple, very interesting concept, Fourier series. So I hope you enjoyed this session. So if you like our video, kindly subscribe and press bell button for upcoming videos notification. Your support is very much needed to do more and more videos. So if you like this, kindly press like button and press bell button. If you are not subscribed yet, kindly subscribe my channel. Okay, so thank you all.